Hey guys, Mr. King here. Hope you're all having a wonderful night. Today we're going to talk about how these electrons move. They either move within an object or they move from one object to another. They create some pretty cool things. They create lightning, they create a shock where you can get your little brother or sister. So they're able to move from one object to another, or they move within the same object. But the key here is it's just the electrons moving. We've talked about how protons and electrons both have charges, but in the case of charging by induction or charging by contact, which we've talked about, it's only the electrons that are moving. It's not the protons. So we're going to talk a little bit about that today. To start you out, we have a little bit of video about how lightning's made. Check this out.
Silence, please. The lightning.
When lightning strikes, a flash lights up the sky. Lightning is a massive discharge of electricity. Powerful enough to kill you.
Clouds contain electrically charged particles of ice. Usually, the positive and negative charges balance each other out. But in a storm, the ice particles collide and the charges break apart, which leads to an accumulation of negative charges at the base of the cloud. The ground is also electrically charged. The negative charge of the cloud and the positive charge of the ground are attracted. When the attraction becomes strong enough, there's lightning.
So that's charging by induction, the way those charges rearranged.
Rub your feet in a carpet.
Here's charging by contact because he's stealing the electrons.
Close to some metal object.
So you can see the electrons are able to move either within an object or they move from one object to another. Now when they move, they can either go really fast or they can go really slow. If they go fast, they're moving through a material which is called a conductor. That allows electrons to move easily through it. Examples of conductors, we've talked about how metals are the best conductors. So when you look at your electronic devices that you have at your house, your iPod dock maybe, or your television, all those have wires on them that are plugged into an outlet in the wall. When you plug in that outlet in the wall, you'll notice your plug is made of metal. That attaches to other metal parts in the outlet in the wall, and that allows the electrons to flow into your wire. And if you look inside that rubber sheathing that covers up your wire, you would see a bunch of different types of metal. Most commonly, you would see copper, because copper is a great conductor. It allows electrons to move really quickly. And that's what you want. When you turn something on, you want the electricity to go through it quickly so it works well. Materials that do not allow electrons to flow easily through them are called insulators. And insulators kind of block those electrons from traveling through them. They have a ton of resistance, and in other words, they just make it really hard for them to get from one end to the other. So you would never want to power any electrical device using an insulator. You would use a conductor. These guys here are playing with a little bit of lightning. They have a source where it's got a bunch of extra electrons, and they are using electricity and they're throwing it back and forth between each other. And you can see as this video goes, you'll be able to see how they kind of share the electrons between each other. They have some different things on that allow them to conduct the electricity better than a normal person would. So check this out. Now these suits obviously protect them from these lightning strikes, so their suits are a great example of an insulator. But the items they're using, they have different metal devices attached to their suits. Those are the conductors. So those allow the electricity to be attracted and flow through it. So if you look closely on his head, there's a metal rod actually sticking out of the top of that suit, and that's where the electricity is attracted to. And that's able to conduct it from one metal rod to another. And those guys are kind of sharing the electrical charges. Now if they didn't have those insulator suits on, this would be really dangerous because there's a lot of power in those millions and millions of electrons that are built up there. And you can see when they join the electrons together by sharing them between them, it's a much greater bolt of electrons because you have twice as many. And all you're seeing is just a ton of electrons built up. That's what that streak is. So they've harnessed so many electrons that it's creating almost like a lightning bolt. So when those guys are sharing those electrons, it's because it's a static charge. Okay, a static charge is an imbalance of electrical charge on an object. So they have some device that's creating a ton of electricity and it's not flowing into anything. It's just putting it into the air. Therefore, those electrons are looking for a place to go, and so they go to the metal on their suit because those metals are good conductors. So they are sharing a static charge. That's the exact same thing as if you were to take your shoes off, if you got shoes on and you just have socks on and you rub your feet on the carpet. It's the exact same thing, except they have billions and billions and billions of electrons and you might have a couple thousand. So if you rub your feet long enough on the carpet, you get a stronger shock. Some of you guys have probably felt a shock on a trampoline. And that's because every time you bounce up and down, you're coming into contact with that trampoline and you're stealing electrons from it. So when you get off, if you grab one of the metal springs, there's a good chance you've been shocked. The movement of that static charge from one place to another is an electric discharge. And in small cases, it's just called a shock. But in other cases where you have a ton of electrons built up, we call it lightning. And that's all lightning is just a huge buildup of electrons. And you guys know electrons can travel from one object to another when they come into contact with one another. And so that's what happens in the clouds. They come into contact, those frozen particles bump into each other, they transfer electrons, and then some have extra electrons that they need to get rid of, and that's when you see lightning. So lightning is just a static discharge between two clouds, or between the cloud and the ground. You can also have lightning that goes from the ground to the cloud. It can actually rise from the earth and go up to the clouds. Now, in order for that to happen, if you guys think about what you've learned so far, it's pretty simple. What happens is you have extra electrons in the ground because there is a cloud overhead that has extra protons. And so you have an attraction between the one that has extra protons, and the way that cloud would have extra protons is when it bumps in, it loses some of those electrons to another cloud. That would allow the electrons from the ground to travel up to the cloud. And that happens a lot. So we really have three types of lightning. Now, cloud to ground is the most common. That's the one you see. Cloud to cloud is really common too. If you see a big flash in the sky and you don't really see any streak coming down to the ground, that's cloud to cloud. And that would make sense because as the clouds come into contact with each other, one steals electrons from another. That means one is positively charged, the one that gave up the electron because it's got more protons, and one's negatively charged because it's stolen an electron, so they're attracted to each other. So that electron's shooting into another cloud. That's cloud to cloud. We do have a special kind of technique for making sure lightning doesn't burn out buildings. And it's called grounding. And that's where there's a huge pole on top of a building and it's made of metal, and that attracts the lightning to it because it's a good conductor and it's high up in the air, and that harnesses the power from the lightning so that it won't go through a building or through a home and short circuit everything and blow all your fuses and pump too many electrons into your different devices and ruin them. So that's called grounding, where you kind of provide a path for it to go through so it doesn't ruin everything. I'm going to show you a little video about some ground to cloud lightning. Okay, so check out this. This is kind of the rarest, but this shows in slow motion, and you'll be able to see how it comes from the ground and moves up to the clouds, which once again, it's just a matter of where are the extra electrons at and how are they going to move from one space to another.
The leader is shot up from the tower tip and goes upward.
The images Tom has filmed over the last few years have astounded the world of lightning science.
You can see that's rising up from the ground, shooting up to the clouds, and all that is a bunch of electrons searching for protons. They're attracted to that because they're opposites. And obviously, when you see a lightning strike, it's hard to tell whether it came from the cloud or came from the ground because it moves so quickly. So this slow motion photography helps you kind of see the way it goes. There's some cloud to cloud. You can see tons of it going from side to side. Then you also have this one streak that's kind of growing and moving. Okay, it's pretty cool the way they move from one cloud to another. And all this is, once again, it's just electrons. It's just a ton of them. And they're just searching for a proton because they're attracted to it because they're opposites. So you can see lightning moves in all those different ways. To help you guys understand a little bit more, I'll show you a little bit real quick what this would look like. If you've got the ground here. And let me get a little smaller tool here. On the ground or within the ground, you have that same idea of the ground is normally balanced. You have the same number of protons and electrons, and they balance each other out. Now in the clouds, I'll give you one more electron here. In the clouds, it's also the same. Most of the time up in the clouds, you have an equal number of protons and electrons. We're going to balance these out. Once again, same number means they're electrically neutral. Now what happens is this cloud and this cloud are going to run by each other. They're going to bang into each other, and you guys have seen lots of different times where in a thunderstorm the clouds move by each other and you can see them kind of going across each other. So what happens is when they go across each other, we have that charging by contact idea. So we're going to steal, this cloud is going to steal these electrons. So now this has 2 extra electrons, so this results in a negative charge. Now remember, the particles that move are the electrons. So what happens is, in this part of the ground over here, this cloud has a negative charge. And since it has a negative charge, it is going to send these negative electrons down to the other half of the ground. So they're going to be pushed away because remember, like charges repel each other. They don't want to be near each other. So what happens is, this part of the ground seems positive, so these electrons shoot down and you get your lightning. Okay? Now in this case, this is where we're going to get our ground to cloud. These have positive charges. Down here, this is balanced. But because this has more positive charges, this is actually going to draw the negative charges out of the ground and make them attracted to the protons. So that's the ground to cloud. And then the last type would be where you have cloud to cloud, and you can see pretty easily how this could happen. When these go across each other in steel, this one has 5 electrons, this one only has 1. So these electrons are extras. So these 2 electrons just can shoot across and they can match up with these to get it back to balance. So lightning, 3 ways. You got cloud to ground, ground to cloud, and cloud to cloud. And as you can see, in all cases, all it is the movement of electrons. All right, guys, have a wonderful night. Get that quiz done on the back. I will see you tomorrow.